This question, we have two functions. F of x is 2x minus 5. G of x is x squared minus 3x plus 7. And I have a few questions based on those functions. So the first one I have is to evaluate f circle g of 2, which in North America, f circle g of 2 means f of g of 2. So to finish this, we need to determine what g of 2 is. We're going to plug g of 2 in, substitute g of 2's value for g of 2. So we see g of x is x squared minus 3x plus 7. So what that means is g of something is something squared minus 3 times something plus 7. But what is the something I need? I need g of 2. So g of something is something squared minus 3 times something plus 7. G of 2 is 2 squared minus 3 times 2 plus 7. So g of 2 equals 4 minus 6 plus 7. G of 2 equals 11 minus 6. G of 2 is 5. So we can replace 5 with our g of 2, replace g of 2 with 5. So now I have f of 5. Now, what does f do? F of x is 2x minus 5. So f of something is 2 times something minus 5. So the something here that we need is 5 again. So lots of 5s in this problem. 2 times 5 is 10 minus 5, and here's one more. So f circle g of 2, which is f of g of 2, equals 5. Now I'd like to check this on my graphing calculator. So I'm going to use y1 to stand in for f. I'm going to use y2 to stand in for g. So f circle g of 2, using the graphing calculator, will be f of g of 2, or y1 of y2 of 2. That's what we're going to ask the graphing calculator to do. So let's go there and check our work and see if that's what we get. So I'm going to define f. F is 2x minus 5. So I go to my y equals button here, just to make sure you see where that is. Y equals button 2x minus 5. 2x is up here, minus 5. And then g, which I'm calling y2, g is x squared minus 3x plus 7. X squared minus 3x plus 7. So I have successfully defined f and g just as y1, y2 using the notation from the graphing calculator. Now I need f circle g of 2, I need f of g of 2, I need y1 of y2 of 2. How do I do that? Vars, y vars, function y1, that's f of y2, vars, y vars, function y1 of y2 of 2, and I hope the answer is going to be 5. So we'll hit enter and see what we get, and we have 5. So that's good. That reinforces what we did on paper. So check. Our next question is f circle g of x. So this time we have to create a new function. How does that process work? F circle g of x. Well, f circle g of x is f of g of x. That's what it means. F circle g of x means f of g of x. But what do I know? What is g of x? Well, g of x is x squared minus 3x plus 7. So I'll replace this g of x with that value. So this now becomes f of x squared minus 3x plus 7. But what does f do? F of x is 2x minus 5. So f of something is 2 times something minus 5. What is my something here? My something is 2 times x squared minus 3x plus 7. F of something is 2 times something minus 5. So 2 times x squared minus 3x plus 7 minus 5. Now let's distribute this. So 2 times x squared is 2x squared minus 2 times 3x is 6x, plus 2 times 7 is 14, minus 5, and I get 2x squared minus 6x plus 9 is f circle g of x, same as f of g of x. You know, I like to check. So I'm going to check to see if that is the same graph as, remember, f was y1, circle y2 of x, which is y1 of y2 of x. I want to see, is that the same as 2x squared minus 6x plus 9? So I'm going to quickly check that on my calculator. You'll remember that I have y1 and y2 already in the calculator, and I want to see what is the function y1 of y2 of x. Y vars. y1 of vars, y vars, function y2, y1 of y2 of x. And I don't really care to see the other two functions. I just want to see the new one I created. So I'm going to click on the equal sign and it turns it off. So now you'll notice the black function is y3. Whatever the calculator graphs will be y1 of y2 of x. So I'm going to go with zoom standard, I think, to look at that function. Oops. And what do I get? Can I see any of it? There we go. So that is f circle g of x, or y1 of y2 of x. Notice that's in black. Now, what did I think the answer was? I thought it was 2x squared minus 6x plus 9. So let me go ahead and graph that function and see if they match up. So I want f circle g, which is my y3 there, to be the same as what I think it is, 2x squared minus 6x plus 9. And this will graph in pink. So let's look at our grapher and see if they match up. So the black one is f circle g, and the pink one is 2x squared minus 6x plus 9. And they sure look the same. So that's a pretty good indication that I've done that correctly. All right, so nice to check your answers to make sure you haven't made an arithmetic mistake somewhere. So that's f circle g. Now, typically f circle g and g circle f are different. Let's see if that's the case here. So we see what we have. We have f, we have g. Next, I want to get g circle f of x. So g circle f of x is g of f of x. But what is f? F of x is 2x minus 5. So I replace the f of x with 2x minus 5. But what does g do? G of something is something squared minus 3 times something plus 7. Something squared minus 3 times something plus 7. What is that something? That something is 2x minus 5, right? So 2x minus 5 squared minus 3 times 2x minus 5 plus 7. So I need to do 2x minus 5 squared. That often causes some trouble. So let's just quickly do that. I like to use the multiplication box to visualize that process. Let's take a look at it. 2x minus 5 squared. 2x minus 5 times 2x minus 5. I have 4x squared minus 10x minus 10x plus 25, and I get 4x squared minus 10 minus 10 minus 20x plus 25. So that's 2x minus 5 squared is that 4x squared minus 20x plus 25. Minus 3 times 2x is minus 6x. Minus 3 times negative 5 is plus 15. Plus 7. So what do we get? Let's look for like terms here. 4x squared, negative 20x and negative 6x would be minus 26x. And then 25 and 15 is 40 and 7 is 47. So I believe that is G circle f of x. Remember, our G that we had on the graphing calculator was y2. Circle, our f was y1. So I want to see if y2 circle y1 of x is the same as that. Using the graphing calculator notation, it'll be y2 of y1 of x. So let's jump back to the calculator and check our work. So we're going to switch this up. That's gone. And that's gone. This time I want to look at y2 of y1 of x. Vars, y vars, function y2 of y1 of x. Vars, y vars, function y1 of x. So this is taking those two functions, composing them, G circle f. What does the graph look like again? I'm going to go to Zoom Standard. And we get this picture. Hopefully we'll see something as we wait. There we go. So there's a few points on that graph. So that is G2 circle, G circle f, or Y2 circle Y1. Now, what did I think it was? I thought it was 4x squared minus 26x plus 47. Well, you're not going to be able to just look at that graph and say, well, obviously that's the same graph. You better go ahead and draw a picture and see where you are. So let's compare it now to 4x squared. (4x squared minus 26x plus 47). Now this is going to be drawn in pink. Remember, the black graph we just saw was G circle f. Do the black and pink graphs line up? So what you're looking at now is G circle f. The pink graph draws right on top of it. So a pretty good indication that we've done that correctly. Now the last question I have here is to solve for G circle f of x equals 11. Well, we just said that G circle f of x was 4x squared minus 26x plus 47. That's G circle f, and that is supposed to equal what? That's supposed to equal 11. This is a quadratic function. If I want to use the quadratic equation, I need it to equal 0. So subtract 11, subtract 11. Where does that put me? 4x squared minus 26x, 47 minus 11 is what? Plus 36 equals 0. That does not make me very happy. That looks unpleasant. I can make it a little easier if I divide everything by 2. Divide by 2, divide by 2, divide by 2, divide by 2. And the resulting equation becomes 2x squared minus 13x plus 18 equals 0. Is this factorable, or shall I use the quadratic formula? That's the question you can ask yourself. Let's try to factor it. Let's see if we get anywhere quickly with this. So I have 2x squared and I have 18. 2x squared here plus 18 here minus 13x there. Well, 2x squared's got to be 2x times x. 18 could be 6 times 3 or 9 times 2. Or 1 times 18. So let's take a look. If I go to 9 times 2, that would give me 18 here and 2 there, and no way to get 13 out of 18 and 2. If I go with 2 and 9, that would give me 4 and 9. Oh, there we go. So make this -2. make this -9. -2 times -9 is +18. -2 times 2x is -4x. -9 times x is -9x. Add them together, I get -13x. Oh, that wasn't so bad. So we have 2x minus 9 times x minus 2 when we factor that. So that's what I get here. I get 2x minus 9 times x minus 2 equals 0. So 2x minus 9 is 0, or x minus 2 is 0. So continuing here, adding 9 to both sides, 2x is 9, divide by 2. X is 9/2. Over on this side, add 2, x is 2. So I believe my answers are 9/2 and 2. Now let's make sure we understand the question. The question was, when was g circle f of x equal to 11? So when was this thing equal to 11? So I believe I can also solve that on the graphing calculator. So let's go back there. Let's eliminate the things we don't need. So we know that y4 is correct. So I'll hold on to y4. I'll erase everything else. y3 is g circle f, but again, y4 is equivalent to it. So I am interested in when this function equals 11. So let's look at our graph. So if I go to zoom standard, I'm not going to quite see 11, I don't think. So let's see. Do we have it? Am I waiting? I'm not sure. There we go. I can't see 11 here. I need more y. So I'm going to adjust my window so that my y max goes beyond 10. So let me make the y max, multiply that by 2. And I will certainly now be able to see the 11. So there's 11 coming in black. And here is g circle f of x coming in pink. And I want to find the points of intersection. I have a point of intersection here. Do you believe it could be 2? I have a point of intersection there. Do you believe it could be 9/2 or 4.5? Let's have the calculator help us. Second calc intersection point, which is 5. First curve, fine. That's the black line, y equals 11, enter. Second curve, the pink one, enter, guess. Move it close to the crisscross point, enter. And there's an answer, x equals 2, which agrees with what I said, right? I said one of the answers was x equals 2. Let's get the other one. Second calc intersection point, which is 5. Whoops. Second calc intersection point, which is 5. First curve, now I'm going to get closer to the second intersection point. So there's the first curve, is the black one, 11. The second curve is the pink one. The guess, move it close to where it crisscrosses. What will it give me? 4.5, which is 9/2. So that's really nice. You'll notice we did all of this work to find a point of intersection. We can go ahead and get it reinforced from the graphing calculator. On an exam, I want to see this, right? But certainly you should check your work to make sure you've done it correctly.